part of the lecture, we're going to talk about the different machine processes. The first thing we have to do is set up our speeds and feeds. Just like we did in the shop for the milling machines, we need to take and consider what material are we cutting. And today our project is mild steel, so we're going to be looking at the mild steel. Then we have to look at what kind of cutter do you have. Do you have carbide or high-speed steel cutter? And the one that we grind for our first project is high-speed steel. So if you look at high-speed steel under mild steel, it gives you a range of 80 to 135. That is your cutting speed. In order to find your RPMs on the lathe, you have to take your cutting speed times 4 and divide by the diameter of your workpiece. So usually that calculation requires a calculator. Let's use the low end of the speed chart of 80. We go 80 times 4 is 320. And we have to divide it by the diameter of our workpiece. And our workpiece is 1 3/4. So you'll need the decimal equivalent of 1 3/4. So that's 1.75. That tells us that the suitable RPM for this material and this cutting tool would be 182 RPM. On the lathe, you only really have 12 different speeds you can run. It ranges anywhere from 20 to 2,000 on this machine. So our calculator says that we need to run 182 RPM. The closest one I have is 170. So if I'm going to go 170, I have to put this handle in the middle position. That is in the low range, so I need to put this in low. And X, so this has to be an X, which that handle already is. That'll set your RPM for this machine. So let's talk about the feed rate now. If we look here, this is the same chart we use on the milling machine, but on the bottom half of it, it talks about the lathe. On the lathe, remember, it feeds in inches per revolution. So every 1 revolution on the chuck, the carriage advances so far. Inches per revolution is equal to 1/3 of the nose radius on your tool bit. When we ground our tool bit, on the very end of the tool, we put a very slight radius. Right here on the tool, that's the radius that we're talking about. On this tool, it's about a 15,000th nose radius. So on this cutting edge of the tool, it's 15 thousandths. We have to feed 1/3 of that. So 15.015 divided by 3. So 0.015 divided by 3 equals 0.005. So when you set that up on the machine, we're going to be facing the end of the stock first. So when you face, that's going to be moving on the X travel. So remember, there are 2 feed charts. One is for facing, the other one is for turning. So for facing, we have to go 0.005. 0.005 is right there. So that's CT PD1. CT PD1. So now always double check your settings. You want to be CT PD1. So that's PD1. So we now have it set for the proper speed and the proper feed in revolutions per minute. So the next thing is to get the workpiece in the machine. We're going to use a 3-jaw chuck here for today's demonstration. So we're going to put it in. Leave it stick out about the diameter. If it's 1 3/4 diameter, leave it stick out about 1 3/4 inches. The reason is you don't want to have it sticking out this far. When we go to cut the end of the part, you're going to have a lot of deflection on the part. So to make it a nice, strong, sturdy setup, hang on to about, only leave about the diameter of it stick out. So after we have our workpiece and our work holding device, we have to set up our cutting tools. So your cutting tool is the one that you ground. The tool holder you made on the milling machine, remember the thicker part of the tool holder is the bottom of it. So we'll put the tool in there with the cutting edge on the upper, this is the top, on the left-hand side. So on the bottom side now is where the screws are. So you need to find the right Allen wrench. I think it's this one. Yes. And when you tighten up these tool bits, you want to work away from that edge. That edge is very sharp, so you want to pull the wrench towards you and away from the tool. Now you put this tool holder inside the dovetail tool holder. And you don't want this to stick out too far either. If you leave this stick way out like that, there's no support under there. So keep that short. And you have to tighten up these screws now. So keep in mind, sometimes your tool bit's not all the way back in the slot. If there was a screw right over an open part of this tool holder, I would not tighten that screw. You would just tighten the two outside ones then. So you then put this on the dovetail tool holder. So when you put it on there, you bring it down from the top, and this handle locks it tight. So after you get this in there, you have to check the elevation of your tool. How tall is that tool? Is it on center with the machine? And we're talking about the center line in that direction. There's two ways to check that. One way, you could put this on this side, and then you compare it to the tailstock. As I bring the tool bit closer to the tail center, I can compare it to its vertical height. And that will get you close. And it looks to me like the tool bit's a little bit too high. So I'm going to unclamp the tool holder and then turn these nuts. So that's one way of centering your tool. The other way is to center your tool on the workpiece. So we'll put the tool back in the original position. We'll bring it over to the workpiece. And as I bring it up to the workpiece, you want to use your machinist scale or your 6-inch rule and just pinch it in between there. When you pinch it in between there, you'll be able to stand on the end of the machine. When you're standing on the end of the machine, what you want to check is to see if that ruler is straight up and down. If your tool bit is too high, you will see the ruler leans away from the operator. If your tool bit was too low, it would actually lean towards you. So this method works and it's quite accurate, but it only works if you have a round workpiece in your chuck. If you had a square workpiece or some other unusual shape, then you'd want to compare your tool to the tailstock. So I know my elevation is good. I can clamp my tool holder. And we can begin our machining process. So on this digital display, it shows you where you are in the coordinate system. If you move the top hand wheel, it moves the top numbers. If you move the bottom hand wheel, it moves the bottom numbers. So that means that Z on this display is the length and X is your diameter. So we have our speeds and feeds set. Now our tool is set in the tool holder properly. The next operation is the facing cut. So what I do there is I'm going to start up the machine. I'll have to set the carriage for facing. Remember, this handle changes the feed direction. If this handle is down, it'll control this handle. If this lever is up, it controls this handle. For a facing operation, you're simply cutting off the end of the shaft. So you're going to use the power feed in this direction. So the next step is starting up the machine at the proper RPM that we already have set. And then you want to bring your tool bit close to the material. All right, so let's bring it up just until it touches the end of the material, and you'll see it scrape the end. And then you will take the X hand wheel and bring it counterclockwise. That brings the carriage back away, towards you, away from the material. And now at this point where it's touching, I'm just going to zero the Z-axis. Now on the Z, if you go negative, you're going towards the chuck. Positive goes away from the chuck. So I want to go negative, let's go about 0.02 inches, 20 thousandths. And that'll be a first pass across the end of the material. I'm going to re-zero it there. So now that I have that zeroed, I can go ahead and face off the end of the part. So I'm going to restart the machine. Remember, up is forward. This handle is up, so I know it's going to control this hand wheel. So if I push down the feed lever, you see that handle's turning. So while that handle is turning, it's feeding the tool bit across the workpiece. And you'll see on the x-axis that the numbers are counting down. It's a good idea to use a little bit of coolant. It keeps the tool from overheating, and it helps aid the cutting process. So 20 thousandths is a pretty good depth of cut. It's not a big depth of cut, but it's not a finished cut. After this pass, I'm going to bring the tool out and take a 5 thousandths cut. That's 0.005. It's okay if you don't feed to center because we're going to be center drilling it anyway. So I'm going to leave a little bit in the middle. Bring my tool bit back to the outside. And I'm going to move to 0.005. And this will be my finished pass. I'm going to move away on the Z-axis and then back out so I don't scratch the face of the part. You should have a nice smooth face that is nice finished pass.